Good morning, students. Today we are going to discuss the next topic in the chapter acid, bases, and salt. Today our topic is your modern concept of acids and bases. In the previous classes, we know that acids are those substances which are sour in taste, and bases are those substances which are bitter in taste. Now we will go into the modern concept related to acids and bases. So now the first is your acid. What are called acids? Acids are the chemical substances that produce H plus ion in aqueous solution, and this H plus ion is also known as hydrogen ion. These hydrogen ions, being unstable, cannot exist alone, so they will combine with water molecule and occur as hydrogen ion aqueous or hydronium ion. So either it is written as a H plus ion aqueous or hydronium ion. In both the cases it will remain same. H plus aqueous means hydrated H plus ion, or that is known as your hydronium ion. Now you see, when H plus ion combine with the water, it will form hydronium ion. So either you will write H plus aqueous or you can write hydronium ion. In both the cases it will remain same. Now let us see some example. We have an acid, hydrochloric acid. When it will react with water or it dissolve in water, it will form hydronium ion, and there is production of another ions, that is chloride ion. Here you see this is also hydrated. Okay, so you will see there are the production of two different ions. One is cations, another is anions. Now you see another acid, that is nitric acid, HNO3. When it will dissolve in water, it will form H plus ion, and there is another hydrated ion, that is NO3 or nitrate ion, that is in hydrated form, that means aqueous. Here also you see H plus aqueous means it is also very much similar to your hydronium ion. Now when sulfuric acid is dissolved in your water, then it will form two hydronium ion or hydrated H plus ion, or there is a formation of your sulfate ion. So in all these cases you will find that acids, when dissolved in water, they will first form hydrogen ion, and these hydrogen ion, since they are unstable, in order to gain stability, they will combine with a water molecule and form hydronium ion, which is comparatively more stable than H plus ion. So that's why there is formation of hydronium ion. Now let us see on what basis the acids are classified. So on the basis of amount of dissociation in water, the acids are basically classified into two categories. So let us see. First is your strong acids. Those acids which are completely dissociate into its constituent ions in aqueous solution are called strong acids. That means whenever these acids are dissolved in water, they will change into their constituent ions like cations and anions. For example, you see in HCl, how many ions are there? H plus ion and chloride ion. Here how many ions are there? In H2SO4, hydrogen ion and sulfate ion. In HNO3, how many ions are there? Two, one H plus ion and one nitrate ion. So like this, if they will completely change into their ionic form, they are known as strong acids. Now we have another acid, that is known as weak acid. Those acids which are only partially dissociate into its constituent ion in aqueous solution are known as weak acids. Okay, so what do you mean by partially? Means out of 100 molecules of this phosphoric acid, only 10 will dissociate into hydrogen ion and phosphate ion, and remaining 90 will remain as in the form of H3PO4. And those kind of acid where the majority of the acidic form remains in the undissociated form, they are known as weak acid. Means here there will be no dissociation or almost negligible. Here you see another acid, that is your oxalic acid. We have another weak acid, that is carbonic acid. Organic acids like acetic acid, citric acid, tartaric acid, lactic acid, etc. These are the acids or weak acid which are very often found in our day-to-day life. For your reference, I have given the names for this: H3PO4, that is phosphoric acid, for H2C2O4, that is your oxalic acid, H2CO3, that is carbonic acid, and CH3COH, that is acetic acid. And rest of the acids, their names are already given. Now regarding the chemical formula, that you have to read about these acids in the higher classes. Now let us come on to the next classification of acid, that is on the basis of concentration of hydrogen ion in water. Okay, H plus ion or hydrogen ion in water. So on the basis of that, an acid is divided into two categories. One, an aqueous solution having more amount of acid. Acid means what are acid? Acid means H plus ions or hydrogen ion and less amount of water, they are known as concentrated acid. Okay, so those acid which have higher number of H plus ion, they are known as concentrated acid. It is represented by placing this number, that is concentrated, before the acid. For example, concentrated HCl. Okay, it says that this HCl acid is concentrated form. Now let us see another kind of acid, that is dilute acid. An aqueous solution having more amount of water and less amount of acid, that is H plus ion, and it known as dilute acid. Okay, so what happen in dilute acid, you will find that the amount of H plus ion will be less, but the amount of water will be more. So it is represented by dilute before the acid. For example, dilute H2SO4, that is dilute sulfuric acid. Okay, now let us come on to the next topic, that is your bases. Okay, so what are called bases? Bases are the chemical substances which produces the hydroxyl ion. Hydroxyl ion means OH minus. Okay, on dissolving in water, that is in aqueous solution. What do you mean by aqueous solution? Anything which is soluble in water, they are known as aqueous solution. So let us see few examples. Sodium hydroxide, it is a solid. When it is dissolved in water, it will form Na plus and OH minus ion. Now this act as a base. Okay. Again, magnesium hydroxide is a substance. When it is dissolved in water, it will form magnesium ions and 2 OH minus ion. Now it will behave like a base. Previously it is just a compound. Sodium hydroxide is a compound, magnesium hydroxide is a compound. Again, the third is potassium hydroxide. When it will dissolve in water, it will form potassium ion and there is formation of your hydroxyl ion. So when they are dissolved in water, they will behave like an base. Okay, so now let us know something more about base. All bases which does not dissolve in water. Okay, all bases does not dissolve in water, means there are some bases which are water insoluble. Bases that dissolve completely in water, they are known as alkalis. Okay, so only those bases which are completely soluble in water, they are known as alkalis. I have taken few example of alkali like sodium hydroxide. They say, I have written here the name, KOH, that is potassium hydroxide, CaOH whole twice, that is calcium hydroxide, and another example, that is NH4OH ammonium hydroxide. Now while we are reading this thing, let us summarize something very important, that is all alkalis are bases, but all bases are not alkalis. So you have to keep it in mind, these alkalis, they are base, but all bases are not alkalis. Now let us go to the classification of bases. On the basis of amount of dissociation in water, again the bases are also classified into two types like acid. So see, those bases which are completely dissociate into its ions in aqueous solution, they are known as strong bases. So what are those strong bases? For example, potassium hydroxide, sodium hydroxide, calcium hydroxide. When they are dissolved in water, they will form their respective cations and anions, where cation is your positive charge and anions your negative charge. Now you see weak bases. Then what are called then? Weak bases. So those bases which only partially dissociate into its ion in aqueous solution, they are known as weak bases. Example for that will be ammonium hydroxide, magnesium hydroxide. Why they are called weak bases? Because out of the, suppose let us take the 100 of these molecules. Out of this 100 molecule, only say 95 will remain undissociated, and whereas the 5 to 10 molecules, okay, 5 to 10 molecules may dissociate, and that's why they are known as weak bases. Okay, so now let us move on to the next topic, that is your dilution of acids and bases. Then what do you mean by this process? The mixing of acids and bases with water results in decrease of concentration of hydronium ion or hydroxyl ion per unit volume. Okay, and this process is known as dilution. The acid or base obtained by this process, they are known as dilute acids and bases. That I have already discussed previously, that when a substance is dissolved in water, it will form a dilute solution, and here the solution is acid and bases. Example representation of this is dilute HCl, dilute H2SO4, dilute NaOH. So here HCl and NaOH, HCl and H2SO4, they are acids, and NaOH is a base. Okay, now you see per unit volume means here what we will do is we will keep the acid as it is or base as it is. We will increase the amount of water. So what happened during dilution, the amount of H3O plus and OH minus ion will decrease, and this leads to decrease in concentration of H plus and H3O plus and OH minus ion. Okay, now let us come on to during dilution what happened. We have to take certain precautions. Why? Because this dilution is a highly exothermic process and it can harm you. So let us see what is the precaution. Precaution must be taken while mixing acid and bases with water. Now while diluting acid, it is recommended that acid should be added to water with constant stirring. Stirring means you have to moving always moving with a circular motion or periodic motion, and not water to acid. Now while this also there is another concept that always the acid is added to water, not water to acid, because the process of dissolving acid or a base in water is highly exothermic, means a lot of heat will be evolved during this process, and that's why the lot of precautions must be taken during this process. If water is added, so what happen if somebody forgets and if he add water to the acid, what happen in, you see, the heat generated may cause the mixture to splash out. Splash out means it will comes out in the form of a vapor. Okay, and that vapor contain tiny droplets of your acid, and these may burns your skin, and glass container may also break due to excess local heating. What happen if you are adding acid to a very corner, then what happen, that place become very hot and rest of the become cold. So due to change in temperature, your container may break. Okay, now let us understand another topic, that is strength of acids and bases. So strength of acids and bases depend upon the number of hydrogen ions and hydroxyl ion produced respectively. Okay, so as you know that H plus ion is produced by the acids and OH minus ion produced by the bases. So depending upon their concentration, we can say which is a stronger and which is a weaker. The strength of acid or bases can be estimated by using universal indicator. So in this class we are going to use universal indicator solution to determine whether your acid is strong or your base is strong, or another way, whether is your base is weak or acid is weak. Now let us see what is a universal indicator. It is a mixture of several indicators that I have discussed in the very first class in indicators. So it shows different color at different concentration of hydrogen ion in the solution. So that I have explained in the very second class in indicators, that in universal indicators can show various kind of color change. Okay, and what are the color change and how it will affect the concentration of H plus and OH minus ion, that we are going to discuss in the next class. Okay, so here are some questions based on the topics which I have taught. Here the first question is your concentrate, when a concentrated acid is added to water, whether the process is exothermic or endothermic. You have to tell whether this process heat is absorbed or heat is released. While diluting the acid, why it is recommended that acid should be added to water and not water to acid. So this is also I have explained. Now how is the concentration of hydronium ion, okay, effective when a solution of acid is diluted. Okay, now let us say another one. How is the concentration of hydroxyl ion affected when excess base is dissolved in a solution of sodium hydroxide? So these are the questions that you have to do after reading this concept which I have taught today. So please write these answers of these questions in your homework notebook.